While designing the network, it becomes important to identify at the micro level what all factors are cumulatively contributing to delay. In this module, we shall look at the causes of delay, and we are going to have a look at their effects. Some of these have a pronounced effect, whereas others have a relatively lesser effect. So, we can say that small things which we often ignore in terms of network design play a very significant role in the overall calculation and determining of delay. As we had discussed earlier, the constituents of delay can be considered as 4. When we look at them in more detail, we realize that the propagation delay is dependent upon what media are we using, what is the run or length of that medium, what is the data rate being offered on that particular medium, and what is the frame size that we want to serialize. If we are using intermediate devices, such as switches and routers, we also have to consider what is the switching delay. As a typical example, for a very short 64 bytes frame, 5 to 20 microseconds can be the switching delay depending upon what kind of switching fabric is being used. Above the switching layer, the router delay is contributed by the route lookup, the internal architecture, whether it is memory based, it is banyan tree or whatever, the configurations and the default settings for the routing table size and the routing updates plays an important role. Certain software features which are enabled at a router also have an impact on the overall delay. For example, if we have enabled deep packet inspection, it is going to incur significant delay on the processing at the router. Likewise, the network address translation, the IP security, quality of service, and access control list are some of the factors which have their own effects. For the packets which are enqueued at the router, they suffer from queuing delay. The queuing delay has a direct relationship with what is the utilization. For an underutilized router or an intermediate device with queue, if the utilization is far below 70%, the magic number that we had talked about earlier, we see that the queue depth is going to be smaller than 1. The queue depth starts to grow steadily when we start approaching 70%. So the queue depth has a relationship with utilization as utilization divided by 1 minus utilization. For utilization of 50%, the queue depth is going to be 1. The relationship between queue depth and utilization is expressed here. Here we see, we start with 0.5 and we keep on increasing. We see that with average utilization increasing beyond 75%, the queue depth starts to grow exponentially. The arrival of packets at the network is determined by the traffic intensity. Traffic intensity can be normalized to 1. So, any number of any expression for traffic intensity that gives us a value far below 1, say 0.2 or 0.3, is actually low traffic intensity. With lower traffic intensity, the queuing delay is going to be low because the overall queue depth is small. When the traffic intensity increases, the utilization is going to increase, and hence the packets are going to suffer from exorbitant queuing delay.